I'm Anil Kumar, and here is a solution of question number 12, page 510, Nelson Advanced Functions for my students. Now question here is, solve 4 to the power of x plus 6 times 4 to the power of minus x equals to 5. Indeed, this is a very tricky question, right? Let us see how to solve such exponential functions which are in quadratic form. Yes, they are in quadratic form. Let me rewrite this and then show you how. We could write this function as 4 to the power x plus 6 over 4 to the power of x, right? When we have 4 to the power minus x, it means what? Let me bring 5 on the left side, so we get minus 5 equals to 0. Now, if I multiply both sides by 4 to the power of x, what do I get? So what I'm doing here is now multiplying both sides by 4 to the power of x. Okay, this is what I'm doing, and times this by 4 to the power of x. Then what happens? So 4 to the power of x times 4 to the power of x becomes 4 to the power of 2x, and here we have 6 minus 5 times 4 to the power of x equals to 0, right? So basically we have taken a common denominator and written our equation in this fashion. We can always do that since 4 to the power of x is never 0, so you can always multiply or divide by that number. Now here, let us substitute now. Let's say some number p is equals to 4 to the power of x. In that case, what is p square? That will be 4 to the power of 2x, correct? So we'll do this substitution and rewrite. So p square is 4 to the power of 2x. We get p square plus 6 minus, this is x, 5p equals to 0. Now let me rearrange this. So we get p square minus 5p plus 6 equals to 0. Now that is the quadratic equation which you can factor. Now we are looking for product of plus 6 and sum of minus 5. So two negative numbers which added to minus 5, and product to 6 will be 3 and 2 with negative sign. So we can factor this as p minus 3 times p minus 2 equals to 0. So that gives us two solutions. One is p equals to 3 and the other one is p equals to 2, right? Now once we have these two solutions, then we can actually find the value of x. So what we have now here is that two solutions. One is p equals to 3 and the other one is p equals to 2. Now p is actually 4 to the power of x. So we can write this as 4 to the power of x equals to 3, and here we can write 4 to the power of x equals to 2. Now how to solve them? So let's solve them separately, one by one. Right? Now this one is kind of simpler. We could actually use log, right? Or we could write like this also. Let me show you exponential way. 4 is 2, right? 2 square. So we could write this as 2 to the power of 2x equals to 2. Now comparing their exponents, which is 2x and 1, we can say 2x is 1 or x is equals to half. So that is one solution. Now let us see how to solve 4 to the power of x equals to 3. Now we'll take care of logarithmic properties, that is take log on both sides. So if I take log on both sides, what happens? I get log of 4 to the power of x equals to log of 3. We are taking to the base 10 so that the calculator can be used, right? So we can write this as x times log of 4, that is the power rule, equals to log of 3, or x is equals to log of 3 divided by log of 4, correct? Now we will use calculator to find the answer. So we get log of 4, log of 3 in the numerator divided by log of 4 to get the answer, which is 0.79248, right? So that is the value of x. So now what we get here is two different values of x which will satisfy this equation. So we can clearly write down our answer. One of the answers is x equals to half. The other one is x equals to 0.79248. You can say 0.8 approximately, right? So let me just say 0.8 approximately. But anyway, this is the method to solve such exponential equations. The idea here is to write them in quadratic form, substitute with a variable, solve as a quadratic equation, and then resubstitute and get your value for x. I hope that helps. Thank you and all the best.